Welcome to Data Engineering with Subhadeep. In this tutorial, we will learn how to optimize Python ETL pipelines for memory usage and process massive datasets without crashing your system. A common problem in data engineering is running out of memory when processing large files. Loading a multi-gigabyte file directly into a Pandas data frame can easily consume all available RAM and crash your script. Before optimizing, you need to measure. The built-in tracemalloc library is a powerful tool to profile your Python script's memory consumption. It helps you identify which parts of your code are using the most memory. Here is a practical example. We have a function that loads 10 million numbers into a list. By using tracemalloc, we can precisely measure the peak memory it consumes, which, as you can see, is quite significant. Our first optimization technique is using generators. Instead of creating a massive list in memory, a generator yields one item at a time on demand. This approach keeps memory usage incredibly low and constant, regardless of the data size. Let's refactor our previous function to use a generator with the yield keyword. When we profile the new function, the peak memory usage is almost negligible compared to the list-based approach. This is a game changer for data processing pipelines. When you must use a library like Pandas for very large files, don't load the whole file at once. Instead, process it in chunks. You can read a portion of the file, perform your transformations, and then move to the next portion, keeping memory usage stable. Pandas provides a convenient chunk size parameter in its read_CSV function. By setting this, Pandas returns an iterator. You can then loop through each chunk, which is a smaller data frame, and process it individually, preventing memory overloads. While chunking works, a more modern and often better solution is to use a library designed for performance and large data sets from the ground up. Meet Polars, a lightning-fast data frame library built in Rust that is incredibly memory efficient. Let's compare the code for a typical ETL task, reading a CSV and performing a group by aggregation. You can see the Polars syntax is clean and expressive, but the real difference lies in its performance under the hood. The results speak for themselves. While a naive Pandas approach uses the most memory and chunking reduces it at the cost of speed, Polars is the clear winner, offering both the lowest memory footprint and the fastest execution time thanks to its clever query optimization and lazy evaluation. To summarize, always profile your code first to identify the real problem. Use memory-efficient patterns like generators and chunking. And for new projects, strongly consider using modern, high-performance libraries like Polars to avoid these issues from the start. Thank you for watching this tutorial on Python memory optimization. If you found this video helpful, please like, share, and subscribe to Data Engineering with Subhadeep for more content. Happy coding!